Welcome back. We're going to finish up Chapter 8 today, doing two sections, 8.5 and 8.6. In the first section, it's about special factors. And if you were to look at this, any two numbers that multiply to give you 1 and add to give you 2 are 1 and 1. And this is called perfect squares because we could write this as x plus 1 squared. In the next one, the two numbers that multiply to give you 49 that add to give you negative 14 are negative 7 and negative 7. Again, that's perfect squares because we could write that as x minus 7 squared. Now, this is where it gets a little bit different. If you look, remember, actually we haven't done this. This is a perfect square. It's 3 times 3. And this is a perfect square, 2x times 2x. So this factors into 2x plus 3 times 2x plus 3. Now, if you FOIL that out, you're going to notice that you get 4x squared plus 6x plus 6x plus 9. If you think about ax squared plus bx plus c, our a, this b would have to be double the square root of a and the square root of c. How this is factoring is it's the square root of a plus the square root of c. Because the square root of 4 is 2 and the square root of 9 is 3. So the middle term has to be 2 the square root of the first times the square root of the second, because there's 2 of them. If you look at this, you have ax squared plus root a root cx plus another root a root cx plus c. So the answer for this is 2x plus 3 squared. If you look at the next one, the middle term is 0, so it has to add to give you 0, and the back term is negative 4. That means it's going to be 1 positive and 1 negative. That's how you add to get 0. Now, the square root of the first term is 5, so 5x plus 2, 5x minus 2. This square root is going here. This minus means you have 1 plus and 1 negative. And this square root is going there. This is called the difference of squares. The middle problem can be looked at, the beginning problem can be looked at as a binomial. And when you have a binomial with perfect squares, you can always break it up into 2 parentheses, 1 with a plus, 1 with a minus. The square root of this goes in the front, and the square root of the back goes in the back. Okay, that's a lot of arrows. Let's go to the next slide. So these are the formulas at the top here. If you have a plus b squared, that factors into this. A minus b squared factors from that. So x squared plus 10x plus 25, that would be x plus 5 times x plus 5. It's very easy when there's just a 1 in the front. All right, in the back here, this is a perfect square, which is 4. This is a perfect square, which is 3. And this is a minus. So if it multiplies to give you a positive, and if it adds to give you a negative, it would have to be minus minus. And let's just check to make sure this works. 16x squared minus 12xy minus another 12xy plus 9y squared. That works. That's your answer. You can write it like this. Every single problem you can do the long way. It's just that if you have perfect squares, it's quicker to not do the long way. So like this is a perfect square being 10, and this is a perfect square being 6. Now, this is a binomial. That's only two terms. It multiplies to give you a negative, and it's adding to give you 0. Like I could rewrite this as 100x squared plus 0x minus 36. So it adds to give you 0. So I have my 10x and my 6, and then my signs are one positive and one negative. That means the middle two terms will cancel out, and you'll end up with 100x squared minus 36. All right, the next problem, I'm going to rewrite this over here so I have more space. 81c squared minus 4d squared. This is a perfect square, 9c times 9c. This is a perfect square, 4d times 4d. So I'm thinking that my factored form is going to be 9c plus 4d and 9c minus 4d. One is a plus and one is a minus because it multiplies to give you a negative, and it adds to give you 0, because that again is 81c squared plus 0cd minus 4d squared. So that's my factored form, and that does work. And the last problem on this page, that factors, that's a perfect square, 5m squared times 5n squared. That's a perfect square, 3n times 3n. So this would be 5m squared plus 3n, and then 5m squared minus 3n. That will give you that. So we have multiple different ways that we've factored. The first way we've factored is just looking at something and saying, well, every single one of these have a 3 in common, so I can take a 3 out, and I have x squared plus 5x minus 2. This is not factorable anymore because there are not two numbers that multiply to give you 2 and add to give you 8. So I know that we are done. The next way we factored was taking out the greatest common factor of a thing written like that. Good math terms here. So x minus 5 is the greatest common factor, and then we're left over with 8 plus x. You could also write that as x plus 8. So that would be the factored form. This was gotten from the grouping method, which we'll go over now. So the third way we factored was with grouping, where we grouped the first two and the last two, took out the greatest common factor. So this would be 3a squared left over with 4a minus 3. This would be 5 left over with 4a minus 3. And then we're right back to the problem just that we did above here. So we have our 4a minus 3, which happens to be the exact same. That's what we want. That's fantastic. And we have the 3a squared plus 5 left. So that's the next type of factoring. And then we had the grouping where the parenthesis wasn't exactly the same. So we took out a negative, and then we could write that as x minus 3. And now the parentheses are the same. So our x minus 3 comes out, and we're left over with 8 minus x. And then we did the diamond puzzle, two numbers that multiply to give you a negative and add to give you a negative 3. So multiply negative 40, add negative 3. And if you didn't know this, you could think of a factor tree of 40. The bigger number is going to have to be a negative. Negative 40 and 1 won't work. Negative 20 and 2 won't work. Let's see, negative 4, negative 10 and 4, that won't work. 8 and 5. So negative 8 and 5. So because negative 8 and 5 are our answer, our factored form is x minus 8, x plus 5. And you could have the x plus 5 first. It doesn't matter the order, as long as the parentheses are the same. And then we factored where we had a number in front of the x squared. So we multiply the first times the last. So that's negative 60. So it multiplies to give you negative 60, and it adds to give you negative 11. Okay, so negative 60, that would be, the bigger number is going to be negative. So, well, let's just start writing our factors. So 3 and negative 20. 4 and negative 15. 5 and negative 12. 4 and negative 15 add to give negative 11. So we're done. So negative 15 and 4. Okay. Now we took this and we substituted right there, and we factored by grouping. That was one way to do it. So again, this piece right here is from right here, and we're going to factor by grouping. Another way we could have done this is to draw the box. And we have our 6n squared and our negative 10. That comes from right here. And then our negative 15n and our 4n can be written in either of these boxes. And we're going to fill in the exteriors. So if this is 6, I would need a 2n here and a 3n here. I know I need a 2n because I have to get a 4. And 2 times 2 is 4. So now I have my 3n going to my negative 15. So this would have to be a negative 5. And then does negative 5 times 2 give me 10? Yes. So my factor is 3 plus 2. And then 2n plus negative 5. Or you could have 2n minus 5. If you did the grouping, the greatest common factor here is 3n. We're left over with 2n minus 5. The greatest common factor here is 2, and you're left over with 2n minus 5. You can see the 2n minus 5 is the same, and then your leftover business, the 3n plus 2, you would put there. So these are the exact same answers, either by using the box or grouping. Okay, then the last two examples that I just showed you are the perfect squares. So this is a perfect square, 2 times 2. This is a perfect square, 3 times 3. And I just have to check to make sure this is 2 times the first perfect square times the last. And if it is, it works, and it is. So this would be 2x plus 3y times 2x plus 3y. And then the binomial one, this is 11a, and this is 7b. So it would be 11a plus 7b and 11 a minus 7b. One has to be a plus and one has to be a minus so that you're ending up with that middle term of 0. And if by chance this is a minus right here, these would both be minuses. That way you would multiply to get a positive, add to get a negative, negative, negative. Okay, that was kind of a lot of information in one slide. All right, we're going to just go through and factor a few random sample ones. So the first thing you're thinking of is, can I take out a greatest common factor? Or do I have something special, like the difference of squares? And this is just the last two problems that we did. After you've gotten the greatest common factor out, then you would think, okay, if I have 3 terms, do I have perfect squares, or should I go through the diamond puzzle and solve it? And if you have 4 terms, you're going to look for the greatest common factor first, and you're also going to focus on grouping and then taking the greatest common factor out. So this is our first problem. The first thing I see is it's a trinomial, so I'm going to see if there's a greatest common factor, and by golly, there is. It's a 2. Now that I have the greatest common factor out, do I have perfect squares? 5 is not a perfect square, 16 is, but 5 is not, so this will not work. So now I'm going to do the diamond puzzle. This is the long way of factoring. So 5 times 16 is 80. So it's going to multiply to give me 80 and add to give me 24. So my two numbers are 20 and 4. So I'm going to either do this by grouping now or make the box. So you can either rewrite this whole problem, now don't lose your 2 here, as 5x squared. Instead of the 24, we would have 20x plus 4x plus 16. Or you can draw your box. With your 5x squared, your 16, and then one of these is a 4x and one is a 20x. Both of these will give you the same answer. It's a good way to test yourself, to check yourself, and to test yourself. All right, if we're going to solve by the box method, one of these would have to be a 5. It would have to be this one because 5 needs to multiply to get the 4. So 1 times 4 gives me 4x. Okay, so therefore 5 times 4 gives me 20. And does 4 times 4 give me 16? Oh, this is looking lovely. So our factors are 5x plus 4, and then x plus 4. If you solve by grouping, we'd group the first 2 and group the last 2. Greatest common factor of the first 2 is 5, left over 5x, left over with an x plus 4. I'm going to just bring this 2 down and leave it out front. I might make a little box like this. And the greatest common factor here is 4 with an x plus 4 left over. So inside here, my x plus 4 is the same. I'm going to keep the 2 out front. I've got the x plus 4, and then I've got 5x plus 4. All right, so I just realized that I lost the 2 there. So I need to make sure I don't lose that. In fact, I was thinking about writing like a 2 up here to remind myself that there's a 2 out front. So that's important. It's just so exciting when you finish the box. All right, looking at the next problem. This is a trinomial, 3 terms. There is no greatest common factor. There is not perfect squares, so we're going to do the diamond puzzle. So 2 times 4 is 8. So it has to multiply to give me 8 and add to give me 5. Factors of 8 are 1 and 8, 2 and 4, and that's it. No factors add to give you 5, so this is prime. You cannot factor this. And what that means is this is going to be some sort of exponential floating up in the air with no x-intercepts. If you remember from the last book, the factors give us our x-intercepts, so that doesn't cross the x-axis. All right, this is a binomial with two terms. The first thing I'm going to look at is what's my greatest common factor. I can take out a 2, I can take out 2 x's and 2 y's. Because I have 2 x's and 2 y's, these are bigger. So if I take that out, I have 4x to the 4th minus 9. Now I'm not done, because this right here is still factorable with the difference of squares. This is a perfect square, 2x squared times 2x squared. This is a perfect square, 3 times 3. So this whole thing factors into 2x squared plus 3, 2x squared minus 3. One's a plus and one's a minus because it adds to give me 0, multiplies to give negative 9. I need to not forget my greatest common factor out front, and this is my final form of that factored. All right, this is a binomial. The first thing I'm going to do is take out my greatest common factor, x squared. Left over, I would have x squared minus 1. I have to have that placeholder so that if I check myself, I in fact get the initial problem. So we are not done. This is the difference of squares. That's x times x. This is 1 times 1. So I'm going to bring my x squared down, and then this factors into x plus 1, x minus 1. You could have the minus 1 first or second, it doesn't matter. You can multiply the whole thing out to check and see if you did it right. I have 4 terms. The first thing we're going to do is see if there's a greatest common factor. And there is, there is. We could take a 3 out. If we take a 3 out, we're going to have a 2ax plus 3x minus 31 minus 14a. Okay, next step is to group. Group the first 2. When I go to group the second 2, I cannot have a parentheses next to a negative. You need to always slash and dash. Greatest common factor of the first 2 is an x. I'm just going to bring this 3 down so I don't forget it. So left over, I have 2a plus 3. Now, I want to get 2a plus 3 left over in the second thing. So I'm going to take out, this needs to become a 2a. So I'm going to take out a negative 7. That leaves me with a positive 2a. But a negative 7 doesn't come out of 31. So this is actually prime. It's not factorable because the 2 parentheses aren't the same. Now, let's say this was 7 times 3 is 21. This is not prime. It is 21. I was thinking I did this right. Okay, negative 21. Because 3 times 21 is 63. Okay, all is well. So 7 times 3 is 21. Yes, negative with a negative. These are the same. I have my 3 out front. I now have my same factor factored out. And what's left over is that x minus 7. Okay. Perfect squares. That's the first thing I see. I don't see a greatest common factor anyways, but I do see that this is 5x and this is 2. And is the middle thing 2 times the first times the last? It is. So this factors into 5x plus 2 squared. It's a plus because that's a plus. You can FOIL it out and test it if you'd like. And the last one, 4 terms. There is not a greatest common factor. We're going to group. Greatest common factor of the first two is a g. We are left over with 2 minus h. I'm going to write that as g times negative h plus 2. How's that grab ya? I need this to be the same as this. So normally I would just take out a 4, but if I took a 4 out, I would have h minus 2, and again, I need negative h plus 2. So if I take a negative 4 out, I would have negative h plus 2. And now my factors are the same. So negative h plus 2 is out front, and g minus 4 is the other one. If you happen to have h minus 2 and negative g plus 4, or some version of that, that's the same exact thing. So if you actually negated the first one, these are the same. If everything is opposite, it's the same, because a negative times a negative is a positive. All right, so that was a big, huge conglomeration summing up Chapter 8. I hope it makes perfect sense, and I hope you're feeling very confident with factoring. I will see you all tomorrow.